Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.57. While solving this problem, we will be using total series resistance calculation formula. R equivalent of a series connection is calculated by taking the sum of all resistances connected in series connection. We also will be using parallel equivalent resistance calculation formula of two parallel connected resistances. R equivalent is calculated by taking the product of both resistances connected in parallel connection dividing by their sum. Now move towards the problem. Exercise problem number 2.57. Find resistance RAB in given below figure. This is the circuit diagram of given problem. We have to find total resistance between these 2 points labeled as RAB. We will start solving this problem from right side and will simplify the circuit from right to left. First of all, these three resistances are connected in series connection. We can find their equivalent resistance and replace these three resistances with a single resistance that will have the value of all three resistances. And we know that in order to calculate the total resistance of a series connection, we simply add our resistances values connected in series connection. In this case, the total resistance of these three resistances will be 1 plus 1 and plus 1. It will become 3K. So we can replace these three resistances with a single resistance of 3 kilo ohm. Modify the circuit. Now these two resistances are converted into a parallel connection. So we can find their equivalent resistance by using this formula. R equivalent equal to R1 multiplied by R2 divided by R1 plus R2. In this case, R1 will be 2 kilo ohm and R2 will be 3 kilo ohm. Place the values inside this equation to calculate their equivalent resistance. R equivalent is equal to 2 kilo ohm multiplied by 3 kilo ohm divided by 2 kilo ohm plus 3 kilo ohm. Take the product of 2K and 3K and divide it with 5. The value of R equivalent will be 1.2 kilo ohm. So we can replace these two resistances with a single resistance having the value of 1.2 kilo ohm. Now again these three resistances are converted into a series connection, so we can find their equivalent resistance by adding the values of these three resistances. That will be 1.2 kilo ohm plus 2K and plus 2K. R equivalent of these three resistances will be 5.2 kilo ohm, and we can replace these resistances with a single resistance having the value of 5.2 kilo ohm. Now this 2 kilo ohm resistance and 5.2 kilo ohm resistance are converted into a parallel connection. Again we will use this formula to calculate the value of their equivalent resistance. In this case, R1 will be 2 kilo ohm and R2 will be 5.2 kilo ohm. Place values inside this equation. 2 kilo ohm multiplied by 5.2 kilo ohm divided by 2K plus 5.2K. Solve this equation. Product of 2K and 5.2K will become 10.4K square and sum of 2K and 5.2K will become 7.2K. Now this K will cancel out with K square in numerator and 10.4 divided by 7.2 will become 1.44 kilo ohm. So we can replace these two resistances with a single resistance having the value of 1.44 kilo ohm. Modify the circuit. Now the circuit is simplified and converted into a simple series circuit. We can calculate equivalent resistance between these 2 points labeled as RAB by adding these resistances together because of series connection. So the value of RAB will be 2 kilo ohm plus 1.44 kilo ohm plus 2 kilo ohm. Add these values together, value of RAB will become 5.44 kilo ohm. So this was exercise problem number 2.57. Thank you. See you again in next video.